All right. Sorry about that. So knowing that it's arc length, that's the 2 pi r with the degree measure over 360 equals, and I like to just put AL, so arc length. So then you're looking at what you have. That's measure of angle FGH. So measure of the angle means in here is 30 degrees. FG is 3 units, which is the radius from center to the outer part. So you're just strictly plugging it in. The other thing you want to pay very close attention to is it says round to the nearest hundredth, which means we are going to use the pi button. Usually is what Delta likes. Otherwise, you should look and see what the instructions tell you. So it might be 3.14 for pi or the pi button. I feel like more times than not it is the pi button because it is more accurate. So we're going to do 30 over 360 times 2 times pi times our radius. And that's going to give us our arc length. And if you plug that in your calculator, you can also plug it into Desmos. And that should also give you an answer. But using the pi button, since it's round to the nearest hundredth, we should have 1.57 as our arc length. And that is, like I said, the most face value, straightforward version of arc length possible. Does anyone have a question where anything came from at this moment? Or are we okay for this kind? All right, I'm going to assume we're okay. So the next one, again, this is a really basic one. So EF is 4. The angle EFG is 78. So it's 78 over 360. It does say the nearest hundredth again, and it does say length. So we know it's times 2 pi. Our radius is 4 equals our arc length. Again, that's the pizza crust on a pizza. So just around the outside is a portion of their circumference. Using your pi button, rounding to the nearest 100 is 3.14 is our arc length. So this is an arc. Hopefully you remember that from the other goodies or previous circle units or content. Now, this is the same thing, not hard, except that it says express your answer as a fraction times pi. So this is called leave in terms of pi, and I'm not sure why. It takes me a long time to get you guys on board with this. So leave in terms of pi. All that means is you are doing all the math and then not pressing the pi button. Now, we could also write this formula, everything over 360, so the degree measure times, and it is length, so 2 pi radius, and end up the same exact thing. So we're going to take our angle measure, which is 60, times 2, I'm writing pi because that's where it always goes, times 2 again, over 360 equals AL. Now, do not push your pi button. So it's 60 times 4, which is 240. So 240 over 360, all times pi is AL, is our arc length. 240 over 360, you do want to reduce always because we're in Math 3 and there's no such thing as not reducing at this point anymore. You can use your MathFrac button or anything else you need to do to be able to make that happen. Or in Desmos, however you need to reduce this, use all the skills you have. So in terms of pi, our arc length is 2/3 pi. And so that's, again, when they say leave it a fraction with times pi, leave in terms of pi, anything like that, it literally means just don't push the pi button. Do everything else. Don't use 3.14. You're just doing all the math and then leaving pi. So the next person that needs to go further could use the pi button and go a little bit further than that. Now, this one is a little different because it's giving me, so I want to know what the radius is. My radius is unknown, but I have my angle measure at 72 degrees, and I have my arc length, so all of this length is 2 pi, so it's in terms of pi. So you're still going to take your formula, which is degree measure times 2 pi r over 360, or the 360 can just be underneath the x if it makes you happier that way. Ultimately, it's the same math. And you're going to plug in what you know. So I know my degrees is 72 degrees. I can use a 2. I can use a pi. I don't know my radius, all over 360. And the length is 2 pi. So you can, 272 times 2 is not going to give you a nice, neat number to divide by 360. It gives us not, like I said, not a nice, neat number. So I personally would multiply both sides by 360. And then 72 times 2 is 144. Pi radius equals 360 times 2, 720 pi. And I'm just leaving it in terms of pi because there is still a pi on both sides. And if I want r by itself, I'm going to divide by 144 pi, which is going to take care of the pi that was there anyway. So 144 goes away, pi goes away. And so at this point, it's going to be radius equals 720 divided by 144, which is 5. Now, had this been a multiple choice question, by all means, you could have just used it as is, left off, and plugged in your choices, like plugged in the 5 in the place of radius, because then it would be the same problem as we had before. If it's open-ended, you're using your formula, plugging in what you know, and then isolating whatever we're missing. It's usually your radius. It's really the only thing they can kind of throw out. The only other option would be the measure of the angle. Questions, guys?
No.
Thank you.
No, but I will say that clicking noise is probably the most annoying noise in the entire world.
My pen on the screen?
Yes, it's like echoed or something, and it's like...
I'm sorry. I'll try to use my finger and see if I can write it any better, or if it is any better. If it's not any better, let me know, though, because I'm not going to be able to write very neat. Okay, so IJ is 12. Whoops. Is that better? Did it make a ticking noise now?
No. Sounds a lot better.
All right, perfect. So the angle is 30 degrees. The radius is 12. Find the length of JK. Express your answer as a fraction, again, in terms of pi. So it's going to be angle over 360. Whoops, that's not a 3. Times 2 pi radius equals arc length. So our angle is 360. I'm sorry, it's 30. 30 over 360 times 2 pi. We're going to use the pi button. And our radius is 12. But I said we're going to use the pi button. It said leave it in terms of pi or as a fraction times pi. So we're going to push all the numbers except for pi. So you could do 30 divided by 360 and keep moving from there. Or it's not a nice, neat number. So it might be easier to do 30 times 2 times 12. Then divide that by 360. Because that does indeed give you a nice, neat number. So 30 times 2 times 12 actually gives you 720. So 720 pi over 360 equals the arc length. But 720 divided by 360 is 2 pi, which is our arc length if we answer this one correctly. All right. So this one, again, they're just giving you the arc length in terms of pi. So 72 degrees over 360 we have. It's doing length, so that's why it's 2 pi r, because that's part of our circumference. So we're just taking a chunk out of the circumference, and it equals 6 over 5 pi. So I'm going to do 72 times 2. And I'm going to leave it in terms of pi because there's a pi on both sides, just so I don't have to deal with crazy decimals if I can manage it. So 144 divided by 360 is 0.4, which is not super neat. All right, either way. So that means we are, sorry, it's like I can't think without my pen, which is pretty ridiculous. So 0.4 r pi r equals 6 over 5 pi. 0.4 I would turn into 4/10. So I could use it as a fraction maybe, or really doesn't matter, I guess, times this side by 5. 0.4 times 5 is going to be it's going to be 2. So now I'm at 2 pi r, and you may not do it in this exact same order, and that's fine. And I need r by itself, so I'm now going to divide by 2 pi. And that 6 divided by 2, the pi's get rid of each other, the 2's get rid of each other, so radius is going to equal 3. And about right here, depending on your background and who taught you before me, you may do that differently, and that's fine. At the end of the day, it's just a matter of making sure you get radius by itself, and don't panic because it's a fraction. It is always calculator active, so you can switch in and out of fractions forever and ever and ever. All right, so sector area. The only thing that changes here is your formula, but ultimately the processing is the same. It's plug in what you know, plug it in the calculator, chunk it. Can you do it in terms of pi? Can you solve for a radius? Can you solve for an angle? And can you solve it straightforward? Is really the large chunk depth of these questions. So it's going to still be x over 360, but the area of a circle is pi r squared. And so this is going to be sector area. So we're looking for the cheese and pepperonis of this bad boy, or in this case, the blue section. This does say leave your answer in a fraction, so in terms of pi again, so we're not going to use the pi button. So VW, I would say be real careful and make sure you're paying attention to what they're telling you so you don't accidentally just assume it's the radius. So that's going to be 2 squared pi. Our angle measure is 144 over 360 equals surface area. I'm sorry, not surface area, sector area. 144 divided by 360, and then times 4 gives me 1.6 pi. They want it in fraction form because it's delta, these examples. So your 1.6 needs to turn into a fraction. So it's 144 times 2, so 288 over 360. And then, oh, that is real ugly. And then reduce it if it can be. 288 divided by 360 is not 1.6. So what did I do wrong? Oh, because I did 2. Scratch that. That's not right. 288 is not 144 times 4. It's 144 times 2. That's 576. And then you want to check and see if that can be reduced. And it can, so it's 8 over 5. 8 over 5 pi would be the final answer that Delta Math would want. As far as me and probably lots of other tests and teachers, the 1.6 pi is also fine. But because you're going to be doing Delta and that's these problems, it does need to be fraction or it will not take your answer because it says specifically fractions. All right, so we have the length JK. So this is a good one. This is ESC like. So JK is 5/3 pi. So that's the length of the arc. The angle is 50 degrees. And it's asking what is the area. Leave it in terms of pi. So right now, the easiest way to find the area is if you have the angle measure and the radius. I don't have the radius. So the first thing I have to do, I do have the arc length though, and so I can use my arc length formula. Because arc length. And solve for radius. Then go back, because you will not be done because that is not what the question is asking for, and use that radius for area. So our angle is 50 times 2 pi. Our radius is unknown, and it is 5/3 pi. So from here, 2 times 50 would be 100 over 360 pi radius equals 5/3 pi. I am going to probably multiply both sides by 3. That's what I would do. So give me 300 over 360 pi radius equals 5 pi. And then you can multiply by the reciprocal or multiply the 5 by 360 as well. If you were really good back in the day with your fractions and multiplication, you would absolutely multiply by the reciprocal, which is just flip the fraction, which would do the same thing as what we're doing here, but more each individual step is how I'm doing it. Because a lot of people get freaked out when they do reciprocal because it's a little different than what you do a lot. And we do the multiplication and division of numbers a lot. So from here, we need radius by itself, so we're going to divide by 300. And again, how you get here, 300 pi. 300 pi. Whoops, I crossed those out. So radius equals 600. 6, I lied, 6. So now that the radius is 6, now we can actually answer the question. So this is where you're going to go back and plug in everything you need and solve for the area. So my radius is 6. So we're going to take our degree measure. So 50 divided by 360 times pi times our radius squared, and then get our area. Again, it says leave it in fraction and in terms of pi. So 50 times 36 divided by 360. 50 times 36 is 1800. Again, divided by 360.
5.
Pi. Nice. So then it's going to be 5 pi. And that's it. You're done. It's just a little more of that where you have to stay invested kind of problems. It is 3:10, so I will call it quits on these. If you want to work through them and then email me or text me questions, I will. You're going to run into these examples, though, on your Delta Math today and tomorrow, all of them. But I am here to help. It's just a matter of you. Oh, I clicked the wrong one. It's just a matter of you let me know that you need the help, and I'm absolutely willing and more than willing, especially because we have an EOC coming up and I would like you to kick its butt. And tutoring's every day from 12:30 to 2 if you're running into Delta issues tomorrow. If you want to try them before that time, so then you know you can stop in and get that help. Would be highly recommended. Otherwise, exciting to see all your faces. Lots of new people showing up. I'm excited you're excited about getting those bonus points. And sooner or later, we're going to just be working on EOC style questions as well. Does anybody have any questions for me? All right. Well, you guys rock. I hope you have a fantastic day.
All right, you too, Miss Egg. Bye.
Bye, doll.
You as well.
Thank
Bye,
you.
Miss Sigmund.
Bye,
Have a
doll.
great day.
You too.
Dang.
What?
No one talked after.
I think it's because nobody talked during. What are you talking about? I think it's
Oh, yeah.
because there was all those other new faces in there.